In a previous video, we talked about why we want to show work when we problem solve. In this video, we're going to talk about how to show our work. Now, this one's just an outline. We're not going to go really step by step into each thing, but just kind of covering the basic points of the things that you want to make sure that you include. So first, don't do any steps in your head without an explanation or showing your work. It's okay to think and do stuff in your head, but whatever you do in your head, make sure that it gets on paper somehow. Number two, use scratch paper. You're always going to want to try to solve it a few times kind of quickly. Maybe it's not very neat or organized. Sketch some ideas down, try to solve it. And you don't have to use nice paper to do this. Sometimes in your engineering classes, your physics classes, your instructors are going to want you to use something like engineering paper, which is expensive. So just get some scratch paper. Use old notebooks. Use the backs of papers that you used previously, backs of assignments. One thing that I like to do is there's sometimes a recycling bin next to the copiers at colleges and schools, and sometimes there's stacks of paper in there that apparently didn't print right. One side's completely blanked. It's not a garbage where people throw food into there. I just go and grab those papers out and just use the back side of them. Next, it's okay to make mistakes, and there's no need to erase. This isn't one of those things where it's like, oh no, I made a mistake. Somebody's gonna, it's embarrassing. This is school. It's okay to make mistakes. If you're working for a company or doing research at some point, sometimes erasing looks like you're trying to hide something. You make a mistake, that's fine. Move forward. It's completely fine. Don't freak out about it. Next, make drafts. In your English classes, you're told to make drafts, make some rough drafts, and then later on, make it a little bit more neat, make it more organized, make it presentable, and eventually come up with a final draft. Do the same thing here. They don't have to necessarily be as formal, but again, get some scratch paper and make some drafts. Sketch some things out. See what works, see what doesn't. Then get the paper that you want to turn it in on, get all your drafts together, and start organizing it on a single piece of paper a little bit more neatly. When you're actually start putting this on the paper, I want to see a list or an outline of how you plan to solve the problem. It doesn't have to be an explicit list, just 2 or 3 steps. First, we need to do this. Next, we're going to do this. Finally, we're going to do this. Just maybe a couple steps of how you want to do things. List your assumptions and observations. Sometimes you're going to have some observation that you've made in the past. Sometimes we're going to have some assumptions we have to make, especially in engineering classes. And the problems that we're going to give you, they deal with real-world situations. And real-world situations aren't perfect. We're going to have to assume some things. We're going to have to assume whether a number is perfect. We're going to have to assume whether we have to include wind resistance or any of those things, and make sure that you list those so that later if somebody else looks at it and your number is a little bit different, they can see the reasons for that, the things that you assumed. Next, draw a useful picture or some other graphic. It can be a nice plot. It could be something, but draw something. People tend to be very visual, and so as you draw it, it's going to help you, but it's also going to help the other person who's going to be looking at this as well. Make sure that this is useful and that it's labeled. You put your variables in, you put some numbers in. You're going to want to list out your variables. These are both going to be your knowns or your givens, and the things that you're trying to solve for, your unknowns. Next, list your equations. You can do some simple equation modification here. We're not necessarily plugging in numbers and doing anything like that, but we're just listing out these are the 3 equations that I'm going to use. Next, we're going to plug in the variables. We're going to do it in the way that we did our outline. That's going to help us move through it. And once we plug in those numbers, we're going to start doing our math. We're going to start doing our algebra. We're going to start manipulating. We're going to start doing all those things that are going to eventually give us an answer. Once we do get an answer, I would say you're probably not done. A lot of these problems, these aren't like your math problems when you were in elementary school, where I want you to do 100 of them in a minute. I might only have you do 1 or 2 of them on a test or a homework assignment, depending on how difficult I feel that they are. Maybe most 3 or 4 of them. I expect them to be in depth, and so at this point, make sure that you check your answer. And there's a few ways to do that. We talked about estimation in previous videos and in class. When you first got the problem, hopefully you made a quick estimate about what that value should be. Double check, was it close to what you were thinking? You can also do dimensional analysis. You can do unit analysis. Make sure all your units cancel correctly. Make sure that your answer is in the proper dimension. And then one thing that is sometimes the nemesis of many students that I've seen is, did the question get answered completely? Sometimes there's this little twist at the end where they want you to ask to give the answer in a very specific way, or maybe there's this little thing that you have to do at the end. Make sure that you answered exactly what they were asking you to answer. Lastly, once you get all that stuff down, make sure that you write the answer or answers neatly at the end of all your work with units, using proper significant figures or tolerances if they were asked for. Make sure that you box or highlight the answer as well. Make sure that you get credit after all this work. Make sure that the answer is easy to find and that the answer is there and complete.